Let's take a look at the routing tables inside Linux, and we'll use the command route to view the routing tables and to edit the routing tables. So route on its own shows the routing table for the current machine. So I'm running on my client at the moment. I run the route command and it shows me my routing table. And the table in this case has 3 rows or 3 entries into it. And we'll explain that in a moment. First thing, with a lot of the networking commands, route and others, they will show the results in try to be a human-friendly form versus the raw form. And the human-friendly form often will attempt to convert IP addresses to domain names and maybe present a simple name rather than the actual IP address. And that's okay sometimes, but generally when I'm looking at the network setup, I'd like to see the raw IP addresses. And with a lot of networking commands, route included, if you add the -n option, it shows you the raw or the numeric values rather than the human-friendly values. And if you understand enough about IP addresses, it's probably sufficient to look at the raw values. So you'll often see I use the -n option with some commands without explanation. It's not all commands, route is one of them. The difference being, instead of writing default here, the human-friendly name, it gives this special all zeros address. And here, instead of star, it's got another all zeros address. So I'm going to use that -n option. I'll do that again, route -n. For my client, it shows me a routing table. And the two first columns are very useful. They say, in order to reach some destination, send to some gateway or router. Gateway is another word for router. So if I want to reach a particular destination, and it's usually not one destination, but a subnetwork, then send to a particular router. The others are useful, but those first two, if you can understand them, that's maybe the most important. The mask goes with the destination. Then there's maybe some flags like whether the route is up and whether we use a gateway, U and G. Some measure of the cost of using that route, how often it's used, and maybe the other most important is at the end the interface that we use. The reference is usually not used. They are described further in the man page for route. Describes, of course, the commands in depth, the options, and gives some examples, and describes the output to see the different flags and so on. So, in our network setup, it is like this. We have a client, a router, and a server. So across 2 different internal subnets. All 3 of those Linux VMs have a NAT interface which connects to really VirtualBox, which then connects them out to the real internet. So let's have a look at the routing table for my client. 3 entries. What's the first one say? This 4 zeros destination is a special value, not with respect to IP networking, but with respect to this route command. What it means in the destination column is that it's like star, meaning matches any value. So, and the way that routing tables are used is the longest prefix match. So the closest match of these 3 destinations will be the one that's taken. You can often think of this as the default route. If the others don't match, then if it's all zeros here, then it will match definitely. So this is the default route, saying if there's any destination which really doesn't match the next 2, then send to a router 10.0.2.2 and use interface ENP0S3, which if we look at our network diagram, from the client, if we want to send to a destination which doesn't match the next 2, which we'll come to, send to 10.0.2.2. Although it's not shown on this picture, That is actually the special IP address that VirtualBox uses. 10.0.2.2 you think is here. This is the VirtualBox internal router. And use ENP0S3. Let's look at the other two routes and then come back to that one and we'll see why it makes sense. And we'll go to the bottom. If we want to reach network 192.168.1.0, anyone that starts with 192.168.1, and we know it's a network address because this is the mask that goes with the destination, although it comes in the third column, you can think it goes with the destination. Then send to no gateway, I read this as. Don't send to a router. If we don't send to a router, then the only other option is to send direct. This is saying if there's anyone on 192.168.1.0, we don't need to send to a router, we can send to that direct to them via the LAN, because this is the same subnet as what we are on. In our picture, network A is the network 192.168.1.0. The client and router are on that network. That third routing table entry was saying anyone else on that same LAN, we don't need to send to a router, we can send direct to them. If there was another computer connected to network A, 192.168.1.53, the client would send direct to them, not via a router. So there's no router or gateway in that case. That's what the all zeros mean in the gateway column. Similar, in the second entry, anyone on 10.0.2.0, send direct. And this is using interface ENP0S3. And this is really the network between the client and VirtualBox router. Not shown here, but there's actually, VirtualBox creates its own network for the between that client and this router interface. If you want to send to 10.0.2.2, for example, send direct to them, don't send via router. And then we read the first row and think, well, if it doesn't match 192.168.1.0 and it doesn't match 10.0.2.0, then it will match this, meaning anyone else. Anyone else send to 10.0.2.2, which is our VirtualBox router would send to here, and if the destination was the real IP address out on the internet, then the router would then forward it on to the real destination. We have a bit of a problem. We should have our network set up such that if client wants to send to 192.168.2.22, it should send via our router. And at this stage, we don't have that route present in the client routing table. It's been deleted. I'll add it in a moment to demonstrate how to add a route. But let's just look at the server and the server routing table. I'll just change the fonts a little bit larger. This is the server. So from the other endpoint, the server, which is on the subnet 192.168.2.0, network B, it also is on this special subnet 10.0.2.0 and can send to the VirtualBox router at 10.0.2.2. And the server should be able to reach the client on 192.168.1.0. Let's have a look at its routing table. Starting from the bottom is a good way to read this, because the routing table is not processed in order, it's based upon the longest match. I'll look at the bottom one first. To reach anyone on our subnet 192.168.2.0, send direct. That's the fourth row. Send via S8. To reach anyone on 10.0.2.0, also send direct and send via S3. The second row and the fourth row are really for matching. If there's someone on network B, send direct. If there's someone on this special network between us and the VirtualBox router, send direct. and there shouldn't be anyone else there in our setup, except the VirtualBox router. So that's the two directly attached subnets. And we'll often see when we're directly attached to a particular subnet, we'll have such a route. The third one now, if anyone is on an 192.168.00 subnet, send to 192.168.2.2 via S8, and this is via a gateway or a router. How does that work? If the destination is a 192.168.2. Something, then of these four destinations, the closest match is the fourth one, and we'll send direct. Even though 192.168.2. Something matches the third one, the fourth entry is the closest, and that's how the routing table works. It uses the longest matching prefix, the closest value. So if the destination is 192.168.2. Something, send direct. If it was, say, 192.168.1. Something, then the fourth one obviously doesn't match. The third entry is the closest match, and we'd send to the gateway 2.2. And that entry is the one that allows our server to know about getting to network A. If we're at 2.22, the server, and we want to send to, say, 1.11, 192.168.1.11, then the destination 192.168.1.11 matches the third row, and it tells us to send to router 192.168.2.2, which is the router in the middle. We would send our packet to the router. The router would then do its lookup and direct the packet forward the packet onto the client. So that's the routing table entry we need to reach that other subnet. And that's what we need to add an equivalent one to the client to get it to work. And the first one is for any other destination, which is not a 192.168. Anything, and is not 10.0.2. Anything. Anything else will send to the VirtualBox special router 10.0.2.2, and that will go out to the internet in most cases, our default route. So, what do we do to add a route to our client to get our fourth entry such that if the client wants to reach 192.168.2. Something, network B, we should send to the router 192.168.1.1 via interface ENP0S8. We want to add a route entry for that. So let's do that for the client. And to change the network configuration, we need to have admin rights. I'll use sudo. We use the route command, but with some options. We want to add a route. And the destination network 192.168.2.0. All right, and let's keep going. And net mask, which is actually the third column in our table, 255.255. What should it be? Let's go back to our desired setup. We're saying to reach 192.168.1. Something. So I've made a mistake already. And we're using a net mask of /24. Let's go back and fix my mistake. It's not. Sorry, we're on the client. That is correct. Let's be clear here. We're on the client. We want to reach network B, 192.168.2. Something. Then we add the route to that destination network, and the gateway is going to be 192.168.1.1. So the net mask is a /24, and the gateway 192.168.1.1, the router IP address. And we say what interface do we use, what device, ENP0S8, and that is referring to, from the client's perspective, which interfaces it's going to use to send via. So let's have a look at that command. To add a routing table entry, we use route add, destination network, that's the destination column, 192.168.2.0, and the subnet mask 255.255.255.0, which is the third column, and the gateway 192.168.1.1 and the device. And we need password, and we've added that, and I'll use our routing table to show that that routing table entry is there. So that's how to add a routing table entry. If we compare our client, and that should work, and how can we test that it works? We can use ping from our client and try to contact our server, and we get a response. So our communications is working, suggesting our routing table is working well. So we added this row here. If we compare, and it works fine, it's fine. If we compare it to the server was slightly different. This row was to 0.0. Let's go back and explain that and see the meaning of this. We're saying from the client, if we want to reach 1.0, send direct. If we want to reach 2.0, send to 1.1 for the internal networking. A more general approach would be to say, if we want to reach 1.0, send direct. If we want to reach any other subnet, which starts with 192.168.0.0, send to the router. Now, that's not necessary in this case. It was included in the server to cover the case where if we extended beyond the server, for example, we added network C over here, or in the other direction, a network D over this way, then the routing table entries would still work. So that's why we see a slightly different routing table entry between server and client. But both of them work in this simple internal network. If we did want to delete a particular entry, it's almost the same as adding. Use the same values, but del. And it's gone, and I'll add it back in so our network works. So we can add and delete routing table entries. To see more options on manipulating the routing table and viewing more details, have a look at the man page for route. And that allows you to do some basic configuration of your internal network so you have an internet with correct routing tables.